Yeah, welcome back to Team's Top Notch Academy. We're still looking at differentiation, where we've solved the differentiation using the general methods, and now we're at first principle of differentiation. So we're going to take this as the second method of differentiation that we're going to apply. Please, if you are confused anywhere, make sure to check the videos that I've treated. I've solved for general method, and today we're looking at this. So let's just head because of time. For our first principle. The first principle of differentiation, we need to know that y is introduced to be y plus change in y. All right. Then else we can say s to be what? S plus change in else. So it means if you are given a particular function, you are going to assume y to be that, and also assume s to be what you are seeing there on the chalkboard. So now let's take an example that we are given example as y equals to s raised by 3. So you are asked to differentiate this using the first principle method. So when you're given something like this, what you need to do is to assume y, which is solution. If you assume y to be this, so it means now that y being this now will be substituted. So we have y plus change in y is equals to, then same way we have s plus change in what? Else, all raised power what? 3. So let's expand this power. Now you have s plus change in else, then bracket s plus what? Change in else, also bracket s plus change in else. So if we are expanding that, we need to have this. S times s is s squared. S times change in s is plus s change in s. Then s multiplied by change in x is s change in s. Then change in s multiplied by change in s is change in s squared. All this now multiplying s plus what? Change in s. So now s multiplied by s, that is we have s raised by 3. Then s squared multiplied by change in else, that will give us s squared change in else. Okay, then we come to this s change in s multiplied by else, that will give us s squared change in else. S change in s multiplied by change in else, that will give us s change in s squared. All right, then we come to this s change in s multiplied by else, that will give us s squared change in else. S change in else multiplied by this, we are going to have s change in s squared. Okay, then come to this. Change in s squared multiplied by else, that will give us s change in s squared. Then change in s squared multiplied by else, change in s will give us change in s cube. Okay, so remember what we are having here. Now we have s squared, s raised by 3, then s squared change in s, this is 1. All right, so next one is s squared change in s, that is 2. Okay, then s squared change in s, this is 3. So we're having 3, so it will now be plus 3 s squared change in what? Else. Okay, then we're done with this. Let's say we're done with this, we're done with this and this. All right, so remaining this part, so we're having 1, 2, 3. So we now write plus s changing, sorry, 3s change in s squared. Okay, then remaining this, which is plus change in what? S raised by 3. All right. So remember, whenever you are given this question, that you should differentiate y equals to s raised by 3 being the function you have to differentiate. They must say that as s tends, change in s tends to what? 0. That's what you should have at the back of your mind. Even if it's not given, you should know that change in s is always what? 0. All right. So now, if we have this now, it means that the value of this remains what it is, that the value here will now change to what? The value which is what we're having here. All right, which is s raised by 3 plus 3s squared, change in else, all right, plus 3else change in s squared plus then change in what? S raised by 3. Okay, so if this happens, let's make changing y the subject of the problem or equation. So now, this cannot be changing y is equals to, this will go to the other side, we'll have s raised by 3 plus 3s raised by 2, change in else, all right, plus 3s change in s squared plus change in s raised by 3 minus what? Y. Okay, so having done this now, we need to recall that y was given as s raised by 3. So if you do that now, you need to input the value of y being s raised by 3 into this equation. And if you've done that, you are going to have something that looks like this. Changing y is equals to s raised by 3 plus 3s squared, changing else, plus 3s changing s squared, plus changing s cubed minus what? S raised by 3. So now, this can go against this and we'll be left with changing y equals to 3s raised by 2 changing s plus 3s changing s squared plus changing s raised by 3. So the next method we are going to apply is the next step we are going to apply is to factor out what they have in common, which I believe is changing s that they have in common. So doing that now, you have changing y is equal to changing s, which is what they have in common, and you remove changing s from those factors, you're going to have 3s raised by 2, then plus 3s changing s plus changing what? S squared. And if you do that, you can now know that we need to divide both sides by the coefficient of this, which is what? Changing else. And if you do that, you're going to have changing y over changing else is equals to, so if this goes against, which is divided by changing s, so this can go against this, which remain 3s squared plus 3s changing s plus what? Changing s squared. Now, can I say as changing else tends to what? 0. It now means that wherever you see changing else, you substitute 0, and that will give us changing y over changing else is equal to 3s squared plus 3s bracket 0 plus 0 all squared. And having done that, we are going to get this, that the change in y over change in x is equals to 3s raised to 2, then all these are going to be what? 0. And we now say plus what? 0, which is the same as what? 3s raised to what? 2. And this is what? The answer you get after the differentiation using the first principle method. And let's know whether if what we've got is actually what we're going to get when you apply the general method. Okay? Just look at the exercise. So initially, we're given y equals to s raised to 3. So we apply the general method, now it will now be dy over df is equals to 3 come down, we have 3s raised to, then we have 3 minus 1, which is going to give us 3s. 3 minus 1 is what? 2. And that's what we got from here. Please, if you don't understand what I did there, go and check other videos I've dropped. I've treated this general method. All right? Okay, this is how we solve this. Please, for your own part, solve this for me. Differentiate is y equals to 3s raised to 3. All right? So this is what you do. Solve this and know whether if you are going to get the answer. Then when you solved, make sure you apply this general method and now check to know whether if what you solved is actually correct. Then if you have any question, maybe in terms of solving it, then drop it in the comment section. I will head on to answer you. All right? Take care.